Hello everyone, welcome to join today's event. I'm Minggui Cao. I'm working on ACRN project and now I'm in charge of real-time related feature support and its related issues debugging. Today, I'd like to share a topic about the ACRN real-time management and performance optimization. Here is the agenda. First, I want to talk about the challenges in the real-time VM. We call it RTVM in ACRN. Second, I want to talk about some features what we have done on ACRN to support the RT features. It mainly include the CPU partition, LAP pass-through, and the PCI devices pass-through. Also, there's a CAT configuration in ACRN. And the third, I want to talk about RT data profiling and tuning on ACRN. I'll give you the steps for RT tuning, and also give an example for the best setting and the perimeter RT Linux kernel configuration. Also, I want to talk about VM exist data profiling. This is important to the ACRN. Also, I want to talk about the PMU data sampling. When you're tuning some benchmark, some RT feature in details, we need this feature is helpful. So I will take the security test as an example. Last one, I will give a short summary about that. Now let's talk about the. Let me. You can see a red diagram. This is a typical industry scenario. If on native environment there is just RTVM, RTOS, and the hardware hardware layer, but on ACRN project, there's an extra layer, hypervisor layer. Also, there are other VMs like service OS and HMI. This is for this is a Windows VM. So because this is a complex environment, there are some resource contentions. Like the CPU in our VMs, and they shared some resource, and also GPU, and also the DMA and ML operation on device. It could lead the resource contention. Also, in the hypervisor layer, there are some costs in virtualization, and first like device virtualization. If we use the virtual devices in RTVM, there are some cost. For the virtualization layer, also VM exist is another impact on the RT feature. If we call some instructions like CPU ID, and if we access some specific MSR or operate port L from the RTVM, it could cause the VM exist, which will make the CPU from the RTVM trap to the hypervisor. It will cost some time. Also, for the optimization path in this scenario, that it is there's a longer path to optimize the real-time performance, because there's one extra layer, hypervisor layer, compared to the native environment. So for the RT work we have done on ACRN project, there are two targets. The first one is to reduce the impact of virtualization on real-time performance. The second one is to reduce other VM's interference to RTVM. Now let's talk about the detailed work we have done on ACRN project. For the first one, we use the CPU partition for RTVM. Usually we isolated two physical cores for RTVM. One core is for housekeeping, one core is for RT task. It depends on the detailed RTOS. The second one is for the LA peak pass-through. If we use LA peak pass-through, it can avoid the VM exist, which is caused by device interrupt. And the third one for device pass-through, usually like the acrylic, the network or storage, usually we pass through to RTVM directly. But there are some limitations to RTVMs we need to pay attention. The first one is under this scenario, just S2 epic is adopted in RTVM because the CPU can access the MSR directly. It doesn't need to access the epic ML space, which you could call the VM exist. For PCI devices pass-through, we just support the MSI. For legacy interrupt, it doesn't support. Also, for the pass-through devices, after it is configured during the boot time, guest OS here it means RTVM should avoid to access the config space and the MSIS table. This is an example for the pass-through devices. If you access the config space or MS table during the RTVM runtime, it could cause the VM exist. It will trap to the hypervisor. And for other space, it is passed through to the devices. It will need a trap to the hypervisor. Also, for MSI RQ, it will the device can deliver the interrupt to the LAP directly, to the RTVM directly. It will neutral. The hypervisor will not impact it. This is the main part for ACRN project done. During my speech, if you have questions, you can interrupt me. Another one I want to talk about the CAT feature. It is also an important feature when we tune the RT performance. The CAT, it means the cache allocation technology. Here is a typical diagram for resource sharing. Usually for LLC, this L3 cache, we call it a lateral level cache. It is shared between the CPU cores. We can see between the CPU core and the integrated GPU. On Intel platform, there's a integrated GPU. It also shares the LLC directly. Besides that, the devices also can access it. So with this feature, we usually allocate some cache width to the RTVM cores. We call this cache width is isolated. For the rest of cache width is shared by other cores. I will give you the example here. For GPU part, it also allocated some cache width from a shared LLC. You can see this is an example. The bottom is the LLC resource. The right part we allocate the half of LLC to the RTVM. And the left one, we allocated them to other CPU and the GPU, and the GPU can allocate a part of it. And for this, this is for the CAT. This is some MSRs which used to allocate to configure and allocate the cache width. For a cat, there is a white paper from Intel website. I will give you the name in the last page. This is the cat feature we use on Archon project. Also, if we use a cat, from the RTVM side, it should avoid to invalidate the whole cache. So for this instruction for WB invalid instruction will be trapped into Archon. If it execute this instruction, it will be trapped into Archon and will be emulated by Archon. So in RTVM, it is better to avoid to execute this instruction. Okay, and now I will talk about the RT tuning steps on Archon. Usually, if you you want to set up RTVM on Archon on a new platform, we suggest you can tuning the RT performance on the bare metal environment first, because this is the most simple environment. If the RT performance can meet your requirement, then you can try to set up the hypervisor environment. And for the second step, you can set up the service OS and with just with one RTVM, and there are no other workload we call without noise. And on this environment, you can tune the RT performance. If it can meet the requirement, then we can go to the third step. Third step, you can see we add another VM. We add the HMI or other. It depends on your requirement. For the industry scenario, usually there is HMI LVM. We also can run some workload on the HMI and then tuning again. This is from the simple to complex step. It can reduce your issues complexity. So it could be helpful if you set up the hypervisor on a new platform. Here I will talk about some detailed settings. Actually, for best setting, this is at least some main items on Intel hardware. This is the same with the native environment. The first one, we need to disable the hyper. It is better, not a must. It is better to disable the hyper threading, because we want the RT task can run on a physical core. The third one, the second and the third one, it is about turbo mode and P state and C state. We want to disable them because it is better that the CPU can run on a fixed frequency for RTVM. If the frequency is changing during the RT task running, it can cause some extra latency. And for the first one, for GPU frequency, we usually set it to 1/3 of its max frequency. For this one, just as I mentioned in this page, that the GPU and the CPU, they share some resource, especially for the LLC's resource. It could, from the GPU side, it could interfere the RTVM task. The task in RTVM. So we'd better to reduce its interference. So set it to 1/3 or 1/2. 1 second is also could be okay. And you can usually we can run the benchmark for some time to check the result. This is the main item for BIOS setting. Also for the I take the perimeter RT Linux as an example. There are some configurations, also they are same on the as a native environment. We give a link for the perimeter RT on ACRN website, GitHub. You can check it. This is the kernel configurations. For this one is we configure the kernel is perimeterable, and for second for no hertz 4, this can reduce the time interrupt, and this is for RCU callback, and for the CPU isolation. Usually for the perimeter RT Linux, we allocate at least 2 cores. We can isolate 1 core for RT core, just run the RT task, and for other cores can run the interrupt and the kernel thread and other thing and other task force. This is the kernel parameters we configure. Actually, it is same as a native. I just listed for example. This is for assisted PState, we disable them. For idle, we set it to polling mode because we want the CPU can respond some interrupt immediately. For this is for isolation CPUs. We isolate the core 1 for RT task for RT core. This is for no hertz. This is for RCU callback. And the last one is for IRQ affinity. We set to 0. It set the core 0 to run the RT task, RQ related task. So this there are two. There are 2 examples for the BIOS and the RTVM settings. Now I will give an example for the VMware data profiling. Just as I mentioned, if there are some instructions or some actions, if it trap to the hypervisor, it will add extra latency for your RT tasks. So we better to avoid them. So if there are some VMware list, we can use the tools ACRN trace. This is its link on the project ACRN website. You can use it to catch the data, but it is just how to say a little complex. You need to catch all the data, and after the benchmark running, and use a Python script to pass the data. This is an example. You can see for the left one, it is the VMware list reasons. You can see this is a CPU ID called the VMware list. This is if you execute RT read TLC and some MSR, it calls different VMware list. This is its numbers. How many VMware list happens, and this is the second for each time. How much time it costs in the hypervisor. It can give a total how to say profiling for the VMware list data. Also, we offer the we can use this command in hypervisor console. For this patch, because it is just a debug patch, we integrated in the ACRN 2.0 branch. For this command, it is very convenient to use. During the RTVM, if there are some benchmark are running, you can still use this command. But for the ACRN trace, it is better to after the benchmark run, and you can output the data and analyze it. But for this command, it can catch your data during the benchmark running. So it's in time. This because it is a command. There are some data and it just digital numbers. For this for the digital in the left, also the reasons. It maps to this column. For I just give a short explanation. For this is the time for duration, from 0 microseconds to 2 microseconds, and 2 to 4, and the 42 it is a number. How many VMware it happens, and this is the duration. You can see there are some of them, but for VM1 is for WH for Windows. We don't need to care about it. For VM2, it is for RTVM. We need to pay attention on it. And actually for the CPU1, it is for article. This data is very important. We need to pay attention. If there are some VM it happens, and if it lasts for a long time, we need to check why it what caused the VM list. And for the housekeeping call, maybe we don't need to care about that too much. Because I just I just take an example. Have not to catch so too many data. You can check it, and if you need the VM data information.
Minggui.
Hi.
I have a question for you. If you go back one slide again, it's this command vmx. Did you say it's in the 2.0 branch but not in master?
This the two not in a master branch. It's just the ACRN 2.0 branch. You can check out on the GitHub. It also upstreamed. But just integrated in this branch, because it is a debug patch we our customer required.
So, but are you planning to put that in master as well, or is it just something that only exists in 2.0 and we're not touching it for now?
Just in a 2.0 for a master branch, because there are some code lines requirement, so we dropped this feature on the master branch.
Okay. Thanks for the clarification.
But it can apply to the master branch for patch. And now I will talk about the PMU data sampling. PMU 8 means the performance monitor unit. It is an important component in Intel CPU. It can be very helpful when you analyze the performance for your benchmark or for your RT tasks. Here I take the sector test as an example. We will see the detailed data in the next page. Self-test it is it usually used in a real-time system latency analysis. You can see it works like this. When there are a lot of loops. In each loop, it will call a nanosleep. There are some time to set. This here, for example, by default, it is 1 millisecond to set, and this is the expected return. Usually, it is the time set 1 millisecond, but actually, because for the interrupt and the task scheduling, there are some latency. For this is the actually returns. So the latency between the data between the expected and the actual returns, we call it is latency. So you can see it can measure latency in real-time system called by hardware or firmware or the operating system. This is a normal benchmark for the real-time test. And before it running, we need to do some configuration, just as I mentioned in the RT preliminary RT Linux configuration. For the core 0, we set it as a housekeeping core, and for the RT core, we set the core 0, core 1, and we bind all the RQs to core 0 except the local timer. Also, we bind all the RCU tasks to core 0, and set all tasks, non-RT task to parameter 0. And for the sector test, for this parameter, it means we set the Affinity CPU core 1. The sector test will run on the core 1, and its priority is 18, and it will run 24 hours. And this is max latency to check. And here I give an example for the after all the data we sampled, and we export, and we use the Python script to handle it. For the vertical, it is the number for each latency. For the horizontal, it is the latency for each data point. We can the unit is nanoseconds. So we can see for most of the test points, it is smaller than 4 microseconds. But we can see there are still some outer layers. It is more than 10 microseconds. For the outer layers, for the RT requirement, it is important to avoid the outer layers. So if there are some outer layers happens in the benchmark, we'd like to know the root cause and to try to avoid that. So if the PMU data can be offered, it's very helpful to analyze the root cause. So we did an enhancement feature to profile the PMU data in the benchmark. We upload the sample data here. For here is just a simple example. We will set the PMU registers by some shell scripts. After we share here, it means the cache misses. We will check the cache misses, and after set the PMU registers, then we can run the cycle test. For the last parameters is what we add. It means for this one, for actual sample, for random sample, we give it 500 data points. It means it will sample 500 data points. And for this one, for max check, if the latency is larger than 5 1,000 nanoseconds, it will sample the PMU data. So the detailed PMU data can be sampled and with the cyclic test data. And here is an example. We import all the PMU data to the Excel table, and we can analyze the latency, the outliers. For the first row, it means you can see the first. This is the latency for the first column, and it means the cyclic test latency. For times, it means which loop we sample the data. For the third one, it is about the instructions. In this loop, how many instructions it run this time? For cycles, how many cycles, CPU cycles it run for this loop? This is TSC time. How much time it spend for this loop? This is for L2 cache misses. How many misses, L2 misses, it happens during each loop. This is for L3 cache misses. For here we use the cat feature, so the L3 always 0. This is the cycles, the CPU cycles because L2 misses. This is the CPU stores. How many stores, CPU stores? Because L2 cache misses. Because if there are some instruction or data and the CPU can't get directly, the CPU could stores. It depends on the pipeline. And for last 4 column is about the L3, L1, and usually we will get this cache misses during the benchmark running, and after we import them to the Excel table, we can check if here I just give some of them. You can check the outlier. If there are outliers, we can check if it is caused by the L2 misses or L3 misses. If there are too many L3 misses, maybe you can check there are some memory, maybe the cache was or there are some cache competition maybe by other tasks. Here we found if there are even there are some outliers, the L3 cache misses also keep almost 0, and for L2 cache misses almost smaller than 10. But we found there are stores. The stores are different, and the stores are different. We can use the Excel tool to analyze it. This is the latency, the relationship between the latency and the CPU stores by L2 misses. We can give them almost they are correlated. We can analyze this latency. The outlier also the outlier could be related with this one, with this PMU data. So we can check further its root cause. We also can use it just to check which PMU data is really related with the latency, and then we can have the important clue to check root cause. That is what we did for the detailed PMU data analysis. Actually, there are some other tools like perf. They can catch the PMU data, but they just has statistical data, not so detailed for each outlier. So this is different from the perf from other tools. Yeah, open source. You can, if you need it, you can check it. Actually, it also can use on the native environment. Sorry. Okay. Now I will give you a short summary about that. For a real time on ARCN, the resource partition is important for RTVM. We call it a main point. It includes the CPU, the cache, and the device pass-through, and some others. Also for the RT tuning and profiling, for the BIOS setting or RTOS setting, usually they are same with the native environment. But for the tools to profiling vMeetup data is just used for the ARCN project. For PMU data sampling, there are many tools, and also for the patch we offered, you can integrate it into your RT benchmark or RT tasks to check the outer layers, the exceptions, root cause. Here I give a little some reference resource. You can reference for PMU information. You can reference the Intel SDM, and for optimization steps, there are a lot of information in this menu, and it is the architecture optimization reference menu. For a CAT, there's a cache allocation technology white paper. All of them are public. If you need them, you can download from Intel website. Okay, that's what I am talking about the RT related on ARCN. If you have some questions, you can ask me.
Thank you, Minggui. Is there any question for him? We have another 4 minutes before the end of the session, and we move to the next one. Any question for him?
Yeah, hello, here's Helmut. I have a question regarding support of multiple RTVMs. What are the plans about that?
Oh, for a multiple RTVM, because actually we have tested in our environment. It should be okay, but it need to do some configurations because currently we the reference platform is Tag Lake, Whisk Lake, and just Coffee Lake. We have 8 cores. So we set up 3 RTVMs. It can run, and the report is well as the same RTVM. So actually, it is supported by default default setting. Just you need a different for this. Maybe I'll give you.
So does that mean, Minggui, that if we don't need to change anything in the code, we can just change the scenario?
We don't need to change. We do not need to change the ARCN hypervisor code. Just you need to give it a different the configuration in your launch script for RTVM. You can configure different. No. My mistake. Counter design. We just as Jason said, we have the configure tools. You need to configure. If you need 3 RTVMs, you need to configure the resource for RTVMs. It can support formula configure tool. For by default on the Tag Lake or Whisk Lake, we just configure 1 RTVM. But you can use the configure to configure tools for multiple. It should be okay. We don't need to change the code. Just use the configuration. Okay.
Yeah, just want to add some additional note here. Is that for RTVM, especially for hard RTVM, so we need use dedicated CPU, which means it need to use partitioned CPU. So this configure should be done by configurator during boot time. And also, if you also need to take care of the the cache configuration during the configure time. This should be done in the configurator. If you configure it well, yeah, and your platform have enough CPUs, you can support multi-RTVM well without doing any code change in hypervisor. And the other thing is about the TCC support, which is another RT features. We can enable software run for different RTVMs. For this feature, currently we only support one RTVM. If you need support multi-RTVM for this feature, we are planning to support it, but currently we don't support it.
Yeah, thanks, Santu. Just if you have some questions, you can contact us. We can offer some support for that.
Look, I do, like on this, the one question I have, and I don't know if it's because I've always been a little confused with the UUIDs that we need for virtual machines. And so I think that, if I remember correctly, the list of UUIDs we have in the code today only has one that's labeled post real-time VM. Does that mean we'd need to add one there, or that's not strictly needed?
Yeah, if you use multiple, you need a configure like multiple, and I think the UUID, I'm not sure it is static or generated by the tools. It could be generated by tools. I'm not sure that. Maybe Jason, do you know that for UUID?
So actually, it's a long story. So basically, UUID is some identical for or you can say it's an ID for a VM configure. So because some VM configure are already be done during build time, and it's not configured by the device model. For example, how many the vCPU numbers and also the CPU affinity bit mask or is predefined by configurator in the VM configure. Device model cannot change this. So if you need to find, for example, as I mentioned, RTVM must use partitioned CPU. So a lot of VM defined in VM configure, we actually doing CPU sharing. So for partitioned CPUs VM, we have divided it in UUID for RTVM. So you can just use this RTVM's UUID to find the VM configure for it, and to find the VM configure for the CPU configuration. It must be partitioned. I don't know where I can explain it well.
I didn't quite understand it but that may
maybe it's a little complex. We can talk it offline, or we can talk it email.
You just need to know is that the configuration, actually we have two different sections, two different layer to configure the post-launch VMs. One is hypervisor, and another one is ACRN device model. But in the hypervisor, this configuration actually is predefined by the configurator. We cannot change it.
Okay.
And in the device model, we can change some.
Yeah, but so if we want to set up a second RTVM as a post-launch, then that means we need we need to reserve resources at the hypervisor, which is done by the configuration tool.
Yeah.
But do we need to do anything around UUIDs? Because at the moment there is a limited number of UUIDs predefined.
You can just produce one new UUID for this RTVM. It's okay.
Even if it's not labeled RTVM. If I just use one of the post standard UUID and just do the static assignment to one of those.
It should be okay also. Yeah.
Okay. I think I understand.
Okay, thank you.
Thanks.
Thank you.
Okay. We're kind of slightly over time, but not by too much. So is there any more questions from anyone in the audience? And Helmut, does that answer your question?
I'm not sure, since I needed to patch ACRN to get 3 RTVMs running in my investigations. So Just regarding these UUIDs, but this was back in pre ACRN 2 times, but I still use it in ACRN 2.0. But I'm not aware that something has changed there. If I have a look at the source code, I just can see one RTVM UUID and a lot of other UUIDs, but I don't see the possibility, since there are functions which refer to that UUID. So checking if it's an RTVM and stuff like that, which just queries that UUID, that one and only UUID, and this makes it fairly impossible to have a second one without patches. So this will, and I just know there is some work done to support multiple RTVMs, and I just wanted to know what are the plans about that, so I can configure it. Yeah. Okay.
Thank you. Actually, just I mentioned that we have just tested the 3 RTVM on Coffee Lake a few weeks ago. So if you have some issues, we can talk
okay. So
offline.
And you didn't need any patches, any changes in the source code?
I need to check with my colleagues. Not done by me.
Yeah, I think let's take that. We'll take a note, Helmut, on that one, because I agree.
Okay, yeah.
We need to clarify. It sounds like it's doable, definitely, but I think the key question here is really not so much whether it's doable, it's patching. How do we configure it?
It is doable.
Yeah.
I also had 3 RTVMs running, so.
Yeah, I know, but I guess your question is more about, do I still need to carry offline patches, or will that be kind of more mainstream and just a simple config option?
Mm-hmm. Yeah, right.
But yes, we need to follow up on that one, because it's not, and maybe we perhaps we'll do some sort of a tutorial on how to do it if we find it's not straightforward.
Okay, yeah. Thanks.
You can send a mail to me if you have issues. I will contact my colleagues. Okay.
Yeah. Okay. Yeah. Thanks.
Okay.
Thank you.
Thanks a lot.